On CP1-3, we're going to start by calculating the sum of the interior angle measures of any polygon. Okay, so go ahead and start by playing around with that GeoGebra link in the CP1-3 folder and see if you can't kind of get a bit of a hint on what we're going to be doing. And when you're ready, pop back into this video and we will go through a few examples and figure out our rule. Alright, so if I have 3 sides, I can make one triangle out of that, right? I've just got 3 sides, one triangle, easy breezy. We know that there's 180 degrees in a triangle. That one should be really easy for you. When I get to 4 sides and I have a quadrilateral, if I cut that in half, I can get 2 triangles. 180 times 2 gets me to 360. When I get to a pentagon and I have 5 sides, I can cut this into 3 triangles, 1, 2, 3, which means I'm adding another 180 degrees. So I have 360 plus that new 180 from that extra triangle, so I'm at 540 degrees. When I get over to 6, I have a hexagon, and again, I can cut that into 1, 2, 3, 4 triangles now, which means again I'm going to add on 180 degrees, and I get 720 degrees, right? Because each one of those triangles has 180 degrees in it. When I get to 7, without even drawing it out, I'm going to end up with 5 triangles in there, right? Because I'm going up 1 each time. So I can add another 180, which means I get 900 degrees inside of my heptagon. We're going to quick look at the relationship between the number of sides and the number of triangles. Every single time, I'm just subtracting 2. Which means the number of triangles formed if I have n sides will be n minus 2. And then if I take this number, my relationship to get to that number is just multiplying by 180. So the sum of my measures is going to be 180 times the number of sides minus 2. That is just what the polygon sum conjecture is. The sum of the measures of the n interior angles of an n-gon is 180 times n minus 2. N represents number of sides. N minus 2 represents number of triangles inside. And we're using diagonals to form that. And 180 relates to degrees in one triangle. If you get stuck on a test or on a quiz and you're looking at a pentagon and you're like, gee, I just can't remember, you can pick one point, draw in all the diagonals from that point, and just count your triangles. And you can figure out your formula that way. Okay, the important thing is you're drawing from one diagonal. You don't want to draw from all of them. All right, we're going to find the sum of the interior angles of a dodecagon. Dodecagon is 12. So I'm doing my sum is 180 times 12 minus 2. So I really have 180 times 10, which is 1800 degrees. If I have a 100-gon, same formula, sum is 180. This time it's times 100 minus 2, which is 180 times 98. 180 times 98 works out to be 17,640 degrees. All right, on this last one, we want to know the number of sides if the sum is 1080. So this time, sum is 1080. That has to equal 180 times n minus 2. At this point, I'm just doing algebra. So I can do 1080 divided by 180, and I get 6. If 6 is n minus 2, then n must be 8. All right, if a polygon is equiangular, we can find the measure of one interior angle by dividing the sum by n. In other words, our formula becomes 180 times n minus 2 over n. This only works if it's equiangular or if it's regular, right? Because I'm splitting up my total by the number of angles that I have. So if I have a regular polygon where each angle is 120 degrees, and I want to know the sides, I can say 120 is 180 times n minus 2 all over n. I'm going to zoom in a little bit so I have a little more space. I'm going to multiply by n just to help me do my math. So I have 120n. I'm going to distribute in the same step as well. Is 180n minus 360. I'm going to move that 180 over and I get negative 60n is negative 360. If you want to multiply by -1 to clear that out right now, you certainly can. Or you can just worry about that when it divides out, because then n has to be positive 6. Similar problem, this time each angle is 140. So 140 has to equal 180 times n minus 2 over n. Again, I can move that n over by multiplying and get 140n. Distribute in the same step just to save us a little bit of time. Move the 180 over, I'm at negative 40n equals negative 360. Again, if you'd like to multiply by -1, you certainly can. But that negative will drop out when you divide, and n is 9.